Welcome guys. This is 7th lecture on communication system. In this lecture, we are going to solve assignment problem which I had given you in my previous videos. If you haven't watched my previous video, go to the description below where you can find the link of my previous lectures. Okay, so let's get started toward this lectures. So this is my first problem. It is exponential multiplied with an sinusoidal signal multiplied with an impulse. So in this, I will solve first this impulse. So this impulse is del of 1 minus t. Okay, so taking negative common here, I can write this impulse like this. Now applying my scaling property, that is del of at is equal to 1 upon mod a into del of t, where a is here equal to minus 1. So it will become something like this: t minus 1 equal to 1 upon 1 mod of minus 1 and del of t minus 1. It is nothing but equal to del of t minus 1. So this equation can be written as exponential of t minus 1 sine of pi t plus 5 by 4 and del of t minus 1. Okay, now you can see that impulse is present at time t equal to 1. This is 0, this is time axis. Now impulse is present at time t equal to 1 with an amplitude with an area of 1. Okay, so now applying my product property, that is x of t into del of t minus t naught is equal to x of t naught del of t minus t naught. Here this is x of t and this is my impulse. Okay, so replacing t equal to 1 here. Okay, so I can write this equation as minus infinity to infinity e of 1 minus 1 sine of pi 6 by 4 del of t minus 1 into d of t. Okay, so it will look something like this: minus infinity to infinity e of 0 sine of 3 pi by 2 del of t minus 1 into d of t. So exponential of 0 is 1. This equation can be written as minus infinity to infinity sine of 180 plus 90 del of t minus 1 into d of t. So sine 270 is nothing but minus 1. So I can show you that also how it is. This is my sinusoidal signal from 0 to 2 pi. This is pi and this is 3 pi by 2 and this is 90. This is 0. So here you can see that it is minus 1 sine t, sine omega t, I would say. This is omega t. Okay, so here I can write it as sine omega, sine 180 plus 90 is nothing but minus 1, this part. So I can replace this equation as minus infinity to infinity minus 1 del of t minus 1 into d of t. Since interval of integration is from minus infinity to infinity and it took over my impulse at time t equal to 1. So this part is equal to 1 and replacing here we will get the final result equal to minus 1. So this is my answer of this problem. Okay, this is my second problem. In this problem there is an rectangular pulse multiplied with a sinusoidal and an impulse. So u of t minus 6 minus u of t minus 10 will look something like this, because u of t minus 6 will start from t equal to 6. It will goes like this. This is time axis t, and u of minus u of t minus 10 will look something like this. Start from t equal to 10. This one is minus of u of t minus 10. Here it is minus 1. When I sum both of these, the resultant signal will look something like this. From 6 to 10. And this is t. Okay. This is amplitude is 1. Okay. And we can see that there is an impulse also. So my resultant signal, there is an impulse at time t equal to 5. Okay. This is t. This is del of t minus 5. Now you can see that in this problem we are multiplying impulse with this rectangular pulse. So there is nothing here. The value of the signal here is 0. Okay. The value of the signal here at this particular point is 0 at time t equal to 5. So when I multiply this and this, the resultant is 0. So my answer is 0. Okay. Because minus infinity to infinity of 0 dt is 0. Okay. So this is my third problem. In this problem, we are multiplying an impulse with some algebraic equation. Okay. So impulse is present at time t equal to minus 4. And here I had plotted it also. It is at minus 4. And you can see that the trick of this equation is the interval of integration is from minus 3 to 4. This minus 3 to 4, because it doesn't contain my impulse. So answer of this problem is 0, because interval of integration does not contain my impulse. Does not contain impulse. Okay. So this is my fourth problem. In this problem, we need to find the derivative of our signal. Here we can see that it is t square for t less than 0 and 2 for t between 0 to 2, and it is 3t minus n for t greater than 2. Okay. So this is my signal. Here we can see that there is a sudden rise at time t equal to 0 and there is a sudden fall at time t equal to 2. Okay. So there is a point here is that whenever there is a sudden rise or fall in a signal f of t, and if I differentiate this signal, that is dy dt of ft, there is an impulse at those particular point of derivative signal. Okay. So when I do a differentiation of the signal, there will be an impulse at time t equal to 0 and an impulse at time t equal to 2. Okay. And the amplitude of impulse equal to of derivative part of my signal, wherever the impulse is present, is equal to final value minus initial value. Okay. So if I do a derivative of this signal, there is an impulse at time t equal to 0, and the value of this impulse is equal to final value minus initial value, that is 2 minus 0 in this case, and in this case there is minus 1 minus 2 equal to minus 3. Okay. So this is my signal. Here we can see that it is t square. If I do a derivative, I will get 2t, and if I derivate this linear equation, I will get equal to 3. Okay. Now I will plot our final signal. So my final signal will look something like this. Okay, so here it is, and it is derivative of an dc is equal to 0 since there is an impulse at this particular point. So the value of the impulse is final value minus initial value, that is equal to 2. Okay, so there is an impulse at this particular point. I draw it like something like this. This is 0, and there is an impulse at time t equal to 2. So there is an impulse at time t equal to 0, and the value of the impulses I will write down here. Impulse value equal to 2 minus 0, because this is my final value and this is my initial value. This is for time t equal to 0, and for time t equal to 2 the final value is minus 1 and initial value is 2. So impulses of amplitude minus 3. Okay, so there is an impulse of amplitude minus 3, and after this is my signal, so the derivative of the signal is equal to 3. So the signal will look something like this. The amplitude here is equal to 3. Okay, so this is my final output, and I can write this as dy dt of f of t as equal to 2t, okay, plus there is an impulse at this particular point at time t equal to 0 of amplitude 2 to del of t, and there is an impulse at time t equal to 2. So this is for time t less than 0. This is for particular time t equal to 0, and this is minus 3 del of t minus 2. This is for t equal to 2 plus 3 for t greater than 2. Okay, so this is my final answer. So this is the resultant signal d by dt of f of t. I hope you like my lecture, and if you like my lecture, please subscribe to my channel and share it to your friend. Okay, you can also find the PDF notes of this lecture on my blog. Okay, thanks and goodbye.